So hello everybody, good afternoon or good morning if you are from the US. Welcome to our webinar called Understand Your Data Dependencies, Key Enabler to Efficient Modernization. We have a lot of stuff today here, so let's review what we've got here. At the beginning, because this event is shared by two companies, Profinit and Manta, I will shortly talk about organization of the event. Then a few things about challenge number one, your data dependencies. Then we will focus on Profinit modernization framework in more detail. And then I will hand over to my colleague from Manta Tools, and we will talk about Manta Showcase. At the end, as usual, there will be space for Q&A, and I will talk about it part a bit later. So a short introduction at the beginning. So who we are. So my name is Michal Petrik, hard to spell in any language but Czech. I'm from Profinit, and shortly about Profinit. We've been here for more than 20 years. We are in business for more than 20 years. We focus on extraordinary talents, focused on IT. We support startups, student competitions, and of course, we also do computer science education for kids. And we collaborate with computer science universities in the Czech Republic. And one part which is really important for this event today is focused on Profinit modernization framework. That is our framework we have developed for software systems modernization. What a surprise. So it was about me. If you need to contact me, you see the stuff down there. And now I will hand over to Jan, and he will introduce himself.
Thank you, Michal. My name is Jan Ulrych, and I'm part of Manta, and I'm actually responsible for the research and education in Manta. So Manta is a lineage platform that helps you discover the dependencies in your environment, and then these dependencies can be used to help you augment and optimize your existing processes. And I'll be happy to share one sample use case about that to tell you more.
Okay, Jan, thank you very much. Now, shortly about the organization of the webinar. As you can see, it's so important we put 2 times webinar in the headline. Sorry for the mistake. A short introduction in the beginning, and as you can see, we have 2 times here. So for Europe, if you are seated in Europe, it's starting at 4. If you are in the United States, it's starting from 10. And short introduction of Profinit and what we do for 25 minutes. Then we will move to Manta again for 25 minutes. And at the end, there will be space for Q&As. Because this is, as usual, online event for questions and answers and some polls, we will ask you also questions. We will use platform called Slido. I just sent a link in the chat, so I hope you see it. And of course, you can use your mobile phones or go to Slido and type in event number 2854, and you can collaborate in this event, and you can help us make this event better. And we will try it in a few seconds, so please do not hesitate. Go to Slido and you can share your thoughts with us. So ask your questions. We will get to them at the end. Our colleagues will also monitor your questions, and if any question needs immediate response, we will do, but if not, we will answer all of your questions at the end of the event. So let's get started. Challenge number 1, your data dependencies. And because this is not only about data, but about the fact that the data is the key enabler for your modernization of your software, let's ask the first question. So we assume that you are in the process of modernization, or maybe you are thinking about it, or maybe you just happened to be here and you are looking forward to see what we are going to say. So please go to slide 2 and share your thoughts. Great, so you are thinking about it or you are in the process of it. I'm glad to hear it. Okay, I wanted to say glad to hear that no one is just here, but fair enough. So more than 75. Okay, nice. So we are thinking about it. So here we are able to change your mind, or not to persuade you, but to give you a few tips or hints what you can do about your situation. And now the majority of you knows they are here because of modernization. So let's ask another question, and that's it. What was the driver to start it? What was the reason that you are thinking about modernization or you are doing modernization? This kind of survey is a cloud word, so you can write some things that led you to this modernization stuff. So please do, and therefore we can change a bit our presentation or focus on a few things we have on our slides. So please don't be shy, write something about modernization. Maybe there's a glitch in the network, but who knows? So waiting for the first answer. There are many things that can. Security, okay, thank you very much. I was hoping for something like that, because security is our common friend in many situations, and we have to change our softwares because of security. There may be other reasons. For example, it can be about the data. The data are locked in your systems. Staying competitive, of course, your competition never sleeps, and they are faster, they are more successful, efficiency, and so on. So thank you very much. At least 3 responses, and I hope that you will be more active in later minutes. And as we all can see, it's about security, competitiveness, efficiency, and so on and so forth. But we can use another perspective to analyze our modernization approach. And one of the options is, for example, displayed here. During our presentation, we will use a few graphics provided by Gartner, and very often they can explain a really complex stuff in the most simplest way. And this is one of the situations. Regarding our businesses, there are many influences. We have shareholders, regulators, employees, suppliers, and so on. And of course, we have customers. And actually, the customer side is very often the most important one regarding software systems modernization, because we want to sell our products, we want to provide value to our clients, we want our clients to pay for our services. So we need branches, contact centers, webs, mobile applications, and so on and so forth. And because of all this stuff, we need the data to be available to the customers. And to be honest, this is the biggest issue. Many times we have seen many issues opening the data to the outer world. So if we are talking about software systems modernization, very often we are talking about this part of the graphic. So we are talking about the customers and enabling the data to the customers, sometimes data that is locked in our legacy systems. So this is one opinion, but we can show our opinions. For example, these 2 statements that say more than 80% of data migration projects run over time and or budget, and cost overruns are about 30% in average. That's from Bloor Group, and again from Gartner. 83% of data migration projects either fail or exceed their budgets and schedules. So as you can see, this is a shared knowledge that every project connected to data is about to be complex and definitely not easy. And when we are talking about data, very often it's not located in one system per se. Very often it's about integrations. So we have our software systems, ecosystems that are interconnected. We are using one party or one user data in many systems, and when we change one part, it also influences another part. And that's the problem. So again, data modernizations and integrations. So another question, do you know or are you aware of the number of integrations you have in your systems or core systems? So how complex is your situation, or what is the level of complexity of your ecosystems you are going to modernize? Because about 67% of you responded they are thinking about software system modernization. Okay, thank you very much. A really nice number. Somewhere between 100 and 250, 10 to 50, more than 250, or we don't know. And actually, that's the reality regarding big systems and in financial sector or in other very popular areas. This is the case. We have monoliths, we have microservices, we have many things, but the fact is we are sharing the data. So thank you very much. As you can see, more than 10 at least, but I assume somewhere around 100 and more is a typical case. So that's our situation. We have our legacy core systems. We want to serve up data, but we have many integrations. And in our experience, our clients, which are about to modernize their systems, they very often say, okay, I have a big monolithic system and I need to modernize it. And they also think that big monolithic system means it's isolated with clear boundaries, and you change only this part, this specific brick, and you are done. But actually, that's not true, because very often we are not talking about big black bricks we call a monolithic system, but it looks like this night map of Europe. We see big parts, big light parts, for example, big cities, but can we say where does it end? So if we switch the power off, which part is going to be black? Actually, no one can say. So there is a big potential that when we switch the power off, not only the city will go black, but maybe another 20 or 100 kilometers around the city. So we very often call it a butterfly effect. When we change one part of the system and then 20 miles away, something bad happens. Very often that's a bad thing, not a positive one. And this is the case with software systems modernization. We can change one part in data and then we have bad impacts in another part. So when we want to modernize such a system, we should focus on so-called friction points. It means our system is usually big. It has many parts, and we have to identify which part is the most important one or the most problematic one. Again, one graphic provided by Gartner. Let's assume that your system is the blue object down there, not 100% sure where it starts and where it ends, but we know it has a few modules, for example, product planning, channel management, and so on. And let's also pretend that the green rectangles are not ideal, but they are not so bad. So for now, we can leave it for a later time. On the other hand, we have a few modules, for example, pricing, opportunity management, order tracking, and so on, and they are really problematic. And we have to do something about it. For example, we can replace pricing module. In case of opportunity management, we can provide API. In case of order tracking, we can provide API and also extend web graphic user interface. What I want to say with this graphic is that every case is different. So you have your system is unique, your problems are unique. So there is no solution that fixes all. Very often you have to analyze it, isolate the problem, and choose the right strategy how to address the problem. And if you take it round around, what does it mean? Can I use one tool? No, I simply cannot, because I don't know about all the problems I have in my system. Can I use one process how to do it? Maybe, but I assume usually that is not the case. Can I use only one technology? Rarely. Very often I have to be adaptive. I have to improvise. So at the end, with a few years or more than 20 years of experience, you end up with something that, for example, we at Profinit call Profinit Modernization Framework. It means a set of tools, approaches, strategies, and processes how to address these things. I will talk about it shortly in a few moments, but our framework consists of these areas. The most important one is assessment process to be able to understand the problem. Then we have to use some toolbox of analytical tools to analyze it, to do the migration, to help the processes. Of course, there has to be a lot of software engineering excellence. The process we recommend to do iteratively, incrementally, and in a safe way. And definitely you don't want to end up with a modernized system, but without further maintenance. So everything has to be done with changes change it with future in mind. And you also see that with every category, I have a Manta logo here, because in every aspect, Manta can help, and Jan will talk about it in the second half of this webinar. Now let's focus a bit on each category, and let's see what is our framework about. The first part is the assessment process. Very often we go to companies which we don't know, and the company doesn't know us. That's not the best starting point ever, but it can be solved. So for example, we analyze the company system perspective. How important is the system? What should be the future of the system? What is the company about, and what is the history of the system of the company? Which technologies or tools are used at the moment? What are the plans? What are the possibilities to use? Of course, we have to analyze the software development process to understand how the system has been developed, or what was the reason the system is the situation it is at the time being. And of course, about the processes. For example, in a few months, if we want to change something, what do we have to do? For example, do we have to contact 10 departments and wait 6 months, or are you doing it in an agile way? Which persons do we have to contact, and so on? So we have to understand the company, understand the problem, understand the system. Right now, definitely you are thinking about the timing of this assessment process, and maybe you suppose, okay, it's going to take years. Actually not. We favor approach fail fast. So when there is no glue with a customer, simply it doesn't work. We want to know it, and we want to say it as it is. So for example, this is some kind of a sample schedule we use with our clients. at the beginning, there are 1 or 2 workshops to have the rough idea of the client and of the system. And then we have three weeks long iterations. And with each iteration, we go deeper and deeper in the problem. And of course, during this process, we can also focus on a specific point, for example, specific friction points. We can be more precise in our estimations. We can be more precise in our planning. And of course, we can also reduce the scope. So very often, this part of assessment process takes 9 weeks at the most. Definitely depends on the complexity of the problem. Assessment process, the key attribute here is the size and complexity of the problem, of the friction point, because when we do know the size and complexity, we can estimate, plan, and also set reasonable expectations on the customer side, and at the end, reduce delays. That's nothing else but con of uncertainty. So the more we know, the more precise we are. And the sad thing here is that very often regarding this modernization at the beginning, we are somewhere here. So let's say 4 times higher or 4 times lower the estimates. So we try to move to the right side of the cone and be more specific, be more precise to understand more. So actually, that's just software engineering principles in practice. Also, to be able to assess the system, we need analytical tools. And what we use, if possible, we use best-in-class tooling available on the market. But for example, if we have to deal with old systems written, for example, in a uniphase framework, there are no tools that could support us. So we write our own tools, for example, for source code analysis, data analysis, transformation, data tracing, and so on, to be able to collect metrics of the system and understand how big it is, or understand where does it end and where does it start, to be able, again, to estimate and to plan. And one more time, every project is unique and there is no one-size-fits-all approach. And very often we have to build our custom tools. And for that, we need, for example, metadata from databases. And in this aspect, and Jan will talk about it later, Manta can help a lot because it can collect metadata from the systems. Another aspect of our framework is software engineering excellence. And here we focus on automation, because let's say that modernizing a system, especially at the beginning of the process, is very often close to research and development process. We don't understand the system, we don't know the system, the customer doesn't know what we can do or what can be done very often. Very often we surprise our clients, okay, we can do this and that. And you have to repeat a lot of things, you have to validate a lot of things, and you have to keep it running. And if there are any problems, you have to be able to revert back to the previous step. So at the end, you need to have automation in place since the beginning of the process. So every step should be repeatable, testable, and revertible, because no one can predict future and prepare for everything. And to be honest, every time there will be a situation when you need to reverse something back. Actually, that happens, and then you need the processes to be automated. What is also a really good practice is to validate pre and post state of the modernization. For example, you are migrating from one technology to another, or from one platform to another, and you are not changing the business logic. Then you want to verify, definitely you want to verify, okay, it worked before, so it works after the migration. And when we are talking, for example, about migrating from Oracle to MS SQL or vice versa, you want to be sure that the data flows the same way. So not only from one technology to another, but also it's about the behavior, about the friction point elimination. So, okay, I extracted this part. Does the rest of the system work the same way? And definitely you want to hear, yes, it works the same way. And therefore you have to have some tooling to assure you, okay, it works the same way. Very often manual control isn't the best choice you can choose. And really big challenge sometimes is finding proper testing data. In a big complex systems with more than 100, 500 database entities, everything is connected. And imagine you want to test only one sample entity, but this sample entity has many referential integrities, I mean foreign keys and so on, to other tables. And to be able to identify all the data needed, that's not easy, and it can take really, really long. So if you have tooling support to find these dependencies and, for example, extract the testing data for you, that's a great benefit. And again, Manta can help here, and Jan will talk about it in the second half of this webinar. Our approach regarding our framework is iterative, incremental, and safe. It means do small steps. In our experience, big bang projects usually end with big, spectacular failures. Actually, if you are the exception, congratulations, and please write something about it, and I'll be glad to read about it. But in our experience, if you want to change everything at once, at the end, nothing works. So we favor iterative approach with small increments. You don't have to call it agile naturally. It doesn't have to be agile. It can be a short, iterative, fixed time, fixed price project. Why not? But it has to be iterative, incremental, and solve one problem and move to the next one. So again, here we favor approach fail fast. If it doesn't work, don't do it. Some customers want to plan everything, and here I mean really everything beforehand. So everything has to be set up before the project starts. Everything has to be clear, and then we start. And during the whole project, we have to follow all these prepared recommendations. Actually, it doesn't work. You have to be adaptive. You have to improvise sometimes. And because of this, short increments and iterative approach helps a lot. But nevertheless, before each iteration increment, we do validation of the friction point. Does it make sense? Do we understand it in enough detail? Okay, let's move on to the next item. Impact analysis. If we change this, what will happen? How long will it take? What is the effort needed? Estimation. How are we going to validate that we did what we wanted to do? It means, is it success or not? Simple thing. At the end of this iteration, are we okay or not? So pre-post validation criteria, or if anything goes wrong, what is our rollback strategy? And that's it. So please, regarding your software modernization, favor iterative and incremental approach. Big bang projects don't work. And before the last part of our framework, I have one more question, and it's about your core system. And the question is pretty easy, and it's, how old are your core systems in general? So if you have more than one, and I assume you have more than one core system, so in average, how old are they? Are they brand new, 0 to 3? Okay, 3 to 5 years or 5 to 10. Anyone 10 plus years? Not talking about COBOL systems or other mainframes, but also with Java or .NET, we can have 10 plus years old systems. Okay, thank you very much. That's great. The winner is 5 to 10 years. And what was this question about? It helps a lot for the next slide. And the slide is about having future in mind. Sometimes our clients say, okay, right now we want to modernize our system and then we are done. Another perspective could be, okay, I want to get rid of my system. I want to buy something, some platform. I will migrate all my data and I'm done. And I will not have to do more investments in a few years. Actually, sorry to say, but this assumption is completely wrong. And the reason is here. Let's say that every system has its fit for purpose, its business value that brings to the customers and to the end users. And it also has its agility to respond to new requirements. And let's pretend, or let's assume for a while, that this fit for purpose, value, and agility declines in a linear way with time. On the other hand, also with time, every system costs more and more, gets more complex, and maybe it also gets more riskier and riskier to change. In other words, for example, technical debt or outdated technologies. And as you can see, this curve is not linear, but according to our experience and also to software engineering domain experience, it gets more an exponential way, and that's the problem. And here there are two important points. The first point is in the year 3. Assume you have a fixed budget for your system, and in year 3, what you invest, half of it goes into keeping the system running and fighting, for example, technical debt or updating the platform. Only half of it goes into new features. In year 5, these two curves cross, and it means starting this point, you have to invest more and more of your money go into keeping the system running, not into new features, and that's the problem. So the conclusion here is, even though you modernize your system or you buy a brand new system, also these systems need to be modernized too. So the best option is to keep the system running and allocate some budget for modernization. And how does this relate to our framework? The answer is easy. All the tooling, all the processes, or the stuff we provide with this framework, it belongs to the customer. All the tooling we write or all the processes we set, it belongs during the modernization process, and also you can use it and you should use it later on. So keep it running, for example, validate each iteration, or to validate your processes or validate your data. So the thing here is, with every modernization, the processes should not stop, and you keep modernizing on and just keep the system running. And at the end, if you don't need the system anymore, then shut it down, and this is completely irrelevant. But if the system is running, you should not wait another 5 years and then allocate another budget for a new modernization. You should simply invest regularly, for example, per year or per month and so on. So that's about our framework, and now there's time to hand over to Jan. So now it's yours.
Thank you, Michal. This was a great introduction and segue to what I want to talk about. And I really love the last slide that you shown about the exponential growth of the maintenance costs and improvement costs for the existing systems, because that's exactly what Manta is trying to help with. We're basically trying to help you keep that curve as flat as possible and not go up exponentially too fast, let's say. So how do we really do that? Let me start with a bit of intro that Michal mentioned at the beginning. But what you're looking at over here is an example of a data environment in a larger organization. So on the very left, you can see your production systems that keep your business alive, that really make you the money. And then they are followed by the analytics platforms. It can be storage, it can be your data lake, it can be your data warehouse, it can be your machine learning. There are some reporting and so on. And these are really the systems that should allow you to make the data-driven decisions, right? The complexity that Michal was talking about, the complexity of the environment, definitely grows with the number of systems that you have, right? So if I have 5 systems, it's going to be a less complex environment than if I have 10 systems. But even more importantly, the complexity of the system really grows with the number of connections and interconnections, the dependencies between them, as you can see over here. And that's really where the domino effect may get things much worse. If something goes bad in one system, that issue potentially propagates further. It cascades, right? And understanding your data pipelines, your data flows, really enables you to really know what you're getting into, what you're doing, prevent issues from happening in the first place, or if it comes to the worst, really figure them at least fast, right? So Manta, as a company, we provide a lineage platform that actually allows you to discover the dependencies in your environment in an automated fashion. So first of all, it connects to your source systems, such as your data stores, your databases, your ETLs, and any other transformation technologies. And it analyzes the code to detect the dependencies and transformations and data flows that are happening to the data in that environment, right? When that's done, and when this metadata is actually available, then we actually publish that metadata and the lineage information to augment and allow you to optimize your existing processes. It can be optimizing your data security processes or data privacy processes, your data quality, and many others. But at the same time, it is the metadata and the data flow information is available to the ad hoc users, like your data architects, data analysts, to perform ad hoc analysis, to maybe build some small utilities that allow you to make some of these processes automated that they have been so far doing in a very manual way. And this is something that is being talked about very often, the dependencies and understanding the environment. But if you think about it and look at the actual projects, it turns out that the reality is not really there. The information is not really available on the right level of detail. It does not cover the whole environment, or it's not up to date, right? Which makes it basically unusable in today's world. So that's a little bit about Manta, but let's focus on how Manta really helps and how it fits into this modernization framework, and why is it so important to understand your data pipelines, how it really helps you. And I was thinking that the best way to do it would be to talk about a particular case from a specific customer. Unfortunately, I cannot share the customer name publicly, but suffice to say that it's a large financial institution managing over $100 billion in net assets. So what was the case here? Customer had their on-premise data warehouse, in their case, which was built in Teradata, and they were looking for new options how to explore and analyze the data that they already had, but also to include new data, especially from the online sources. And over the time, this approach worked pretty well for them for some time, but over the time, it actually started becoming very hard for them to do capacity planning properly, because the volume of data was growing fast. In some cases, they were looking to just use the data for a short period of time, and so on and so on. And basically, they were doing a lot of experimentation. And what they really wanted to do is to enable their analysts and data scientists to do their job and not be limited by the technology or by the current environment that they had. So how did they really approach it? And just a little illustration over here. So that current environment was the Teradata data warehouse that they had. And the to-be architecture for them that they chose to implement was a hybrid solution. So they were still keeping their on-premise environment, especially for the financial regulatory reporting, which was proved over the years. It was validated and working very well, very stable. But they actually chose to include a cloud into the mix, into this hybrid solution. And in their case, it was very specifically Snowflake. And one great thing about cloud is that it actually allows you to scale up as you need. Right? So what the customer did was, when they were doing or starting the new exploration project, they actually imported the data into Snowflake, and they scaled up the Snowflake as they needed, right? When they were done, in some cases, they were actually productionizing the results and moving the code back to Teradata and data back to Teradata if it worked. But in some cases, they were keeping them in Snowflake basically forever and continuing there. But the great thing here was that they could scale up and scale down as they needed. So that was really a flexibility that they were looking for, and that was missing to them previously. So now if we take a look at the Profinit modernization framework, how does it fit to the picture? Basically, the customer realized that the understanding of the dependencies in their environment is the key element to make the whole process much more efficient and basically minimize the risk of breaking anything or affecting the users. Because, as Michal said, the migration process is typically not done as a big bang, but it is done through an set of iterations, right? And basically, in each step of the modernization process, we are relying on understanding of the data pipelines to start with the correct estimates, to set the right expectations with the business, to make sure that we involve the right parties into that modernization or migration process. And even further, to actually automate some of the steps, to make them repeatable, to make them automated, to basically reduce the cost, right? And overall, at the end, they ended up with completing the project in time and actually built a solution which is future-proof with the metadata enabled that helps them with in many other areas that they are dealing with. So now, let's take a look at individual phases and individual steps in this process. So I started the presentation about the environment and how anything you touch in the system has impact on its dependencies, right? So as the customer was looking to split off part of their on-premise data warehouse into the cloud, they really needed to understand what processes use that database to be migrated. And in turn, how will these processes need to be adjusted? Do we need to implement new ETL jobs? Do we need to change them? Do we need to inform any of the consumers of the data? Do they need to do some work to use the new data source? And so on and so on. And how Manta helps is that Manta actually gives you that map, and I'm using the visual representation of the map over here in the bottom right corner, of your environment, of the systems, and how they interact with each other for particular data elements. So over here, you see one particular data element on the left, the little one highlighted over here in black. And basically, you see all its uses in your environment or in that particular environment. And based on the color coding over here, you can see that one data set is being used at least in 4 other systems, right? So having the clear understanding of the data transformations and data pipelines, data usage, is actually giving you very accurate estimates or ability to do very accurate estimates on who you will need to involve, who you are affecting, and not necessarily on the system level, which is a high-level picture that we typically have, but on the very detailed data set or even attribute level, and we can talk to the right people about what should happen, how it should be done. As a side effect, a nice benefit of actually having the visual diagram is the fact that you suddenly have something that you could call a common ground. I'm not sure if you've been to discussions between owners of different systems where you're talking about, what data is being used and how it is being used. It often turns out that those two parties have a very different idea about where the data is coming from, how it is being used, how often it is being refreshed. The visual diagram actually gives you something that I would call a common ground. You see how the data flows. Now you can argue and discuss whether it's right or wrong, or if you need to anyhow change it, but you have a common ground that you can start with. You're not starting with something fuzzy. So that was about the external system dependencies that you get to understand. With this particular case of splitting off a part of the data warehouse into the cloud, customer will need to understand which part of the data warehouse should stay in the on-prem instance and which should be migrated over to the cloud. So they really needed to understand the internal dependencies in the system. So for basically each element, they need to see what's going to stay and what's going to be migrated, and to really understand what's the right place to do the cut, where we are moving into cloud, and making really sure that we know what we are affecting, which pieces we need to change, and how complex they are going to be. As Michal said, modernizing is a sort of constant process, and it is very likely that in previous times and previous modernizations, there have been things that happened where the modernization was already ongoing, but without the metadata, it turns out that there may have been cases where simply some of the data sets have been sort of lost. We've been using them in the past, but we are not using them anymore. And since nobody is sure if there are any consumers, if there still are any consumers, they simply left them there. They are still being populated, but they just sit there and nobody uses them. And this was really something very concerning for this particular project, because migrating anything that is not being used is basically a waste of time, waste of resources, waste of testing effort, and so on and so on. So customer has really decided to use the modernization opportunity to also do at least some cleanup of their environment. And in this case, it was they chose to drop the unused data set. And again, how do you really do that? you first need to know whether someone is using the data set. So first thing was for them to understand how many dead ends they have. And based on that, they have decided if they are, or reviewed whether they are still being used or not. And if not, they were basically excluded from the migration. So that actually helped to save some time and effort. If we go further with the modernization process, really planning and estimating is a critical thing here, because as Gartner and Bloor said, basically 80% of the projects run over time. And one of the key reasons for that is that we originally started with incorrect or inaccurate assumptions about the complexity of the system, right? So the data movement in your environment can be very simple or quite complex, right? There can be some complex calculations that we have not expected, that we have not seen before, and basically our original estimates may be inaccurate, and we need to simply adjust them. So with the understanding of these data pipelines, you can actually start with the correct and detailed estimates without having to invest more work than you would have to do starting with the high-level estimates without understanding the pipelines. So to make it a little bit more concrete, over here you can see a sample data pipeline where the data is being pushed through without any changes. It's just passing through the environment from your production system to your analytics. We're not doing any changes. But the situation can be much more complex, or a little bit more complex. Over here, we start with the two data sets, each with two attributes that are actually being consolidated into a single attribute over the time, right? And we need to understand how many of these cases we have, right? And even further, we need to understand how complex that aggregation or consolidation is. Is it just very trivial, or is it something that requires more coding or more detailed reading? So assessing the complexity is really something that is critical. And one of the complicated things about that is that you will need to get into the detail to be able to actually do the assessment properly. So one of the first things that the customer did was they ran the data pipeline analysis on their whole system to understand that, or to get that high-level assessment. And in their case, it was actually calculated based on the complexity of those data flows. And it also allowed them to decide on the migration approach for them. So what turned out to be happening in their environment is that a simple one-to-one data flows took between 40 and 60% of the cases, depending on the migration phase. That's why there's a range. And they decided to handle these cases with a metadata-driven approach. Basically, the new code was not handwritten; it was generated based on the metadata. Right? And the majority of the metadata was actually coming from the lineage itself. The second group, they called it medium complexity, was something that was basically pattern-based. So over here you can see tables party and party_age, party history. And what was happening in this case was it was a historization pattern. They actually identified 5 to 10 patterns, depending on the part of the warehouse that they were migrating. And again, in this case, since it was some standard pattern or pattern to be at least standardized, they decided to use still metadata-driven approach, slightly more complex, but since it was pattern-based, it could have been generated. The code for it could have been generated. And the last part, which you can see based on the percentage, is also the smallest one, is something that's very complex. There were a few places in the warehouse where there was a very complex transformation logic that was happening to consolidate the data, to aggregate it, and so on. But it was a very small part of the environment. And basically, having this high-level understanding, but based on a very detailed analysis of their environment, allowed them to plan the approach properly, allocate the resources properly, and make sure that as they were going through the phases, individual phases of the migration, they know what is the ratio of simple, medium, and complex parts that they will need to incorporate. And that actually helped them with the time planning, right? Making sure that the time for that particular phase is longer or shorter based on the complexity of the code in there. Perfect. So as you go further in the process, one of the key things is to make sure that the modernization process is ideally as automated as possible, so that the manual effort that you are spending or investing is invested on parts that require the manual effort, right? That require human interaction. But things that can be automated and done through some sort of scheduling mechanism and automated validation and evaluation are things where you can save a lot of time and where it can bring you a lot of value, right? Also reduce the risk. So one of the things that was happening here and that customer did was, instead of testing the code really on particular test cases by the live testers, they actually decided to compare the legacy data flows with the new ones. Basically do some sort of smoke test, right, to make sure if, at least on the high level, the code makes sense. So what did they really do? They basically took a specific object that was to be migrated, and they looked at the data flows and the sources in the legacy system, and they compared them with the data flows in the to-be designed system, right? And if they matched, it was okay. If they didn't match, it went back to the developers to actually review why is that happening, right? So this actually really reduced the load on the testers and allowed them to focus on the advanced test cases instead of focusing on the basic ones. And even better, they were able to account for some minor improvements by handling a list of exceptions during that migration. Michal talked about it in his part, about really preparing the test data and making sure that you have a consistent set of test data that you can run repeatedly is really critical. This is not from this specific customer. This is from a different one, but I decided to add it here for reference because it fits into the whole picture. It is actually a creating of test sandboxes in an automated fashion. So how did it really work? Basically, as you understand the data flows, you can also basically decide what the sources are and what the targets are for a particular piece of functionality. And you can very easily create on-the-fly data replication from, for example, production with masking into your test sandboxes. And that way, you can create on-the-fly test data sandboxes that do not interact or affect each other. You do not, you avoid conflicts between the individual testing scenarios, and they are very much repeatable. So if you want to run the same test in a week or basically any day in a repeatable fashion, this is a great way to do it. And last but not least, again, as Michal mentioned, nowadays approach to migrations is to not do a big bang, but to do a iterative approach, and that may take weeks or months, in some cases even years if it's really a large system. And during that period of time, there are changes happening not only in the new environment but also in the legacy one, and you actually need to accommodate for those changes to be reflected in the migration process as well. Typically, these changes are captured on the process level. So you know that there's a dependency on specific system or specific project, like migration project. So you know that you are notified about the change. But how do you actually effectively assess the impact of those changes and incorporate them into the migration process? You really need to understand where the data is being used in the migration process, whether they have already been migrated or whether they are falling into one of the phases or maybe even the phase that is running right now. And basically running a quick impact analysis that shows you what the changes are and what they affect is basically the best way to get those changes accommodated into the migration process and get them accommodated efficiently, right, fast. So at the end of the migration, where are we really left off, right? We built a system that is actually covered with metadata. And it's not the metadata that was designed at the beginning when we started and maybe went out of date. It is metadata that is refreshed periodically. It is metadata that is captured from the existing system, from the current version of the system, that is really ready to be used. You can use it to optimize your other processes like data operations, incident resolution, or data quality. Or you can use them for a quick ad hoc impact analysis. If you're actually implementing a new change, you have the metadata available at hand and able to use them. And that's really what the customer benefited from, because the investment at the beginning of the migration that they made to start with the metadata-driven approach and analyzing and understanding the data flows really paid off, because the metadata is available, it's up to date, and they can use it for other projects and other processes that they have. And basically, with that modernization, they not only modernized the system itself, but they also modernized the process, how they work with the data. And that's all from me. So thank you very much for listening.
Jan, thank you very much. We are about to close this webinar with a few key takeaways you should take, of course, away. And they are, when we modernize our systems, there are many things that we can modernize. We can rip and replace, we can re-platform and move from one technology to another, and do not touch any business rule or business algorithm at all. Or very often we have to do such a thing. So we are doing something that relates to data, and in that cases, to understand the data dependencies while modernizing is totally crucial to be able to estimate, mitigate risks, do reliable migration, and so on and so forth. So if you are about to modernize your systems that heavily depend on data, and you are not just moving to the cloud, to another platform, but you are changing the system per se, definitely you will touch the data perspective, and then you have to understand your data. And again, be sure that during those many years the system operates in production, your models are a bit connected, your data may be not so clear and understandable to you, and then some tooling might help. Another perspective is it's not about IT staff just doing the migration. It's not also only about the business people saying we want to do things faster, be more competitive, and so on. All these aspects have to work together and properly. And again, one common denominator is the data. It means IT people have to understand what to do with data, understand everything about the referential integrities and so on. And also the business people have to understand about the data flows, and if they change one screen here, what will happen in another screen. So complex and objective view on the challenge. Where does it end? Where does it start? When we do modernization, we should set up automation since the way day one. Definitely you are doing new projects on the green field, and the best practice today is set up your DevOps at the beginning of your project, set up version control, set up everything, and then you are bit safer and everything is a bit easier. And the same applies to modernization. And again, to be honest, sometimes the legacy systems lack all these super features such as automation, daily build, source code, static analysis, and so on. So definitely automation should be set in place since the day one, and only then all the steps can be repeatable, testable, and reversible. And when we talk about data, then the situation is more and more important. And last but not least, of course, thank you for watching this webinar. And that was all about Profinit modernization framework and Manta, and the fact that with these two companies and two approaches, your modernization can be easier when you care about your data and about the state it will be in the future. Okay, we are at the end, right on track, and we are eager to hear your questions. At the time being, we have no questions so far, so that's not a problem, because I assume that the webinar was so clear and so understandable. There are no questions so far, but maybe there's another reason. Maybe you forgot about slido.com. So if you have any question, please do not hesitate to ask it. And of course, this is not the only option to ask your questions. You can write it directly to Profinit or Manta and to ask your questions, and our experts will be glad to respond everything and to give you our support. So what to say at the end? I will leave a few seconds for your questions. If there are no questions at all, the last thing to do about our webinar is to thank you very much for listening to us. Okay, so I persuaded someone. How does Manta integrate with other metadata apps? So Jan, it's for you.
Absolutely. So there are multiple approaches that we use. For some of them, we have out-of-the-box connectors. Some of the metadata apps have out-of-the-box connectors for Manta, and in some cases, there are standard exports that can be used to integrate together. So we can definitely discuss in more detail on specific metadata app that you're talking about, whether it's more on the data governance side, or whether it's more on data cataloging side, or maybe data quality side. Feel free to follow up with a question if I either didn't answer it completely, or you would like to hear more details.
Okay. So no more questions at the moment. So from Jan and from me, thank you very much for listening to us. If you have any further questions, do not hesitate to contact us. And once again, thank you very much for being with us today, and see you next time, for example, with another software systems modernization. Thank you. Bye.
Thank you very much. Have a great day.